Hello everyone. In this practical, we will be looking at the properties of acids. In fact, we'll be investigating into the reactions of acids. So, first I am taking ethanoic acid, adding a few drops of ethanoic acid into a spotting tile and then a quarter of ethanoic acid in a test tube. So I'm adding ethanoic acid a quarter into 3 test tubes. You can closely observe the reactions and the speed with which the reaction is happening, because this experiment is all about the reactions taking place with 4 acids. So first I am taking ethanoic acid and reacting with universal indicator. A few drops of the universal indicator is added, and then I am going to determine the pH of ethanoic acid using a pH paper. So you can see that the pH is around 3. I take a piece of magnesium ribbon and add it to the first test tube. The reaction is very obvious. Magnesium is reacting with ethanoic acid, giving out bubbles of the gas, and the test tube is hot to touch. The reaction is happening with some vigor. In the next test tube, I'm going to add a piece of marble chip. Marble chip is nothing but calcium carbonate. Again, you can see bubbles of gas being formed. The reaction is a slow reaction. This time, the bubbles are being given out very slow. Into the third test tube, I'm going to add copper 2 oxide powder. It is a black solid. I take a quarter of a spatula of copper 2 oxide and add it into the third test tube. Shake well the mixture and leave the test tube for some time, because this reaction is a slow reaction. We will come back at the end of the experiment to see what happens when copper oxide has reacted with ethanoic acid. The next acid we will investigate is dilute hydrochloric acid. Again, I will be taking dilute hydrochloric acid a quarter in each of 3 test tubes. I'm also taking a few drops of the hydrochloric acid in the spotting tile. I will be repeating the 4 experiments which I did with ethanoic acid, the same procedure. So a few drops of universal indicator into hydrochloric acid and determine the pH using a pH paper. This time the reading is 2. Then I'll take a piece of magnesium strip and add it to the acid, hydrochloric acid, and this time you can see that the reaction is very vigorous. You can see the gas coming out very fast, and the magnesium is dancing there, giving out a lot of bubbles. So effervescence is seen as bubbles of the gas is given out. Into the next test tube, I'm going to add a piece or 2 of marble chips. Again, you can see the reaction is quite vigorous. Brisk effervescence taking place with the evolution of a colorless, odorless gas. Into the third test tube, I am adding a quarter of a spatula copper to oxide, mixing well, and I will set aside the mixture till the end of the experiment and see what has happened, because the reaction is going to take some time. You are free to draw a table and record your results in that. The third acid I'm investigating into is sulphuric acid. So I'm having dilute sulphuric acid, and I will be repeating the same procedure with dilute sulphuric acid as I have done with the other 2 acids. So I take the acid in 3 test tubes, a quarter each. A few drops into the spotting tile. And then I'm going to add the universal indicator to the sulphuric acid and measure its pH using a pH paper. So it's between 1 and 2, so it's a strong acid. I take a piece of magnesium and add it to the first test tube, and you can see that a vigorous reaction is taking place. Magnesium is reacting very vigorously with the acid, giving out a colorless, odorless gas, and the magnesium ribbon is slowly disappearing. It is becoming smaller and smaller, and the vigor of the reaction is also decreasing. In the next test tube, I'm going to add a piece or two of marble chip. Here the reaction is not that vigorous, but still you can see the bubbles of the gas being given out. So there is a slight effervescence with the evolution of a colorless, odorless gas. You can see the effervescence taking place. The test tube is becoming warmer as the reaction is an exothermic reaction. So whatever you are observing in each of these reactions, you can make a record of that in a table, and then you can compare the speed of the reaction and what are the reactions taking place. So in this, I'm adding copper 2 oxide, a quarter of the spatula, shaking it, and I will keep it as per the other acids. This mixture has to be kept for some time to see the reaction taking place. The next acid is citric acid, which is a solid. So I need to prepare a solution of the citric acid. I take a spatula measure of citric acid into a boiling tube and add distilled water. I will be stirring the mixture so that the solid completely dissolves with the water and I get a citric acid solution. I repeat the same procedure as with the previous 3 acids. So a few drops of the universal indicator goes into the citric acid on the spotting tile, and then I am comparing the pH with the pH paper. A piece of magnesium is added to citric acid, and you can see that the reaction is quite slow. Magnesium is reacting with the evolution of a colorless, odorless gas. The bubbles formed is relatively happening at a lesser speed. Then I add a piece of marble chip into the next test tube. Again, you can see that bubbles of the gas is given out. The reaction is slow. And into the third test tube, I'll be adding a quarter spatula of copper 2 oxide. Shaking the mixture, I'm going to leave it for some time for the reaction to take place. Now you can examine the 4 test tubes in which we had reacted copper 2 oxide with the acids. You will find that the reactions of ethanoic acid and citric acid with copper 2 oxide gives a colorless solution, with a black precipitate settling down, and for the other two, that is sulfuric acid and hydrochloric acid, we get a blue colored solution in the test tubes. So copper 2 oxide is reacting with dilute acids. The strong acids react and the weak acids do not react.